Welcome back, guys. In this teaching video, I'm looking at 7.2 dividing polynomials. Now 7.2 represents chapter 7 section 2 of the Pearson A level maths pure maths year 1 textbook. Let's have a look at the key fact of this particular section. What is a polynomial function? A polynomial function in the variable x with degree n, where n is the highest power, is defined as f of x is equal to a subscript n, I'll just call it an. So we have an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus plus a2 x to the power 2 plus a1 x plus a naught, where each ai is an element of the real number set. An is not equal to 0 and n is a positive whole number. So that there is a definition of a polynomial. We could have a linear polynomial, a quadratic polynomial, a cubic polynomial, a quartic polynomial, and so on. So today we are going to be dividing polynomials. Let's have a look at some examples. Write each polynomial in the form x plus or minus p in brackets multiplied by ax squared plus bx plus c in brackets by dividing part A, this cubic, by the linear, part B, this cubic, by the linear. Let's have a look at part A. So first of all, I'm going to set up my bus stop sign. So here is my bus stop. Now inside the bus stop, I'm going to put the cubic. X cubed plus 6x squared plus 8x plus 3. Outside the bus stop, I'm going to put the divisor, which is x plus 1. Okay, so this is how I carry out my polynomial division. I take this first term x cubed and I divide by this first term x. So x cubed divided by x is x squared. I then take x squared and I expand it with the x plus 1. So x squared times x is x cubed. X squared times positive 1 is positive x squared. I then subtract these two polynomials. So I've got x cubed take away x cubed, which is 0. Then I've got 6x squared minus plus x squared, which is 5x squared. I can now bring down the positive 8x and the positive 3 as follows. Right, now my first term is 5x squared. So I take 5x squared and I divide by x. Doing this gives me positive 5x. So now I take positive 5x and I expand it with the x plus 1. So 5x times x is 5x squared. 5x times positive 1 is positive 5x. So we can now subtract these two polynomials. We get 5x squared, take away 5x squared, which is 0. 8x minus plus 5x is 8x minus 5x, which is 3x. We can bring down the positive 3. Now the first term is 3x. So I take the 3x and I divide it by x. This gives me positive 3. We then take the positive 3, ladies and gents, and we expand it with the x plus 1. So positive 3 multiplied by x is 3x. Positive 3 multiplied by positive 1 is positive 3. We can subtract these two polynomials. So 3x take away 3x is 0, 3 take away plus 3, which is 3 take away 3, that is 0. Now that 0 represents the remainder. Okay, so this is called the remainder. Since the remainder is 0, this quadratic is a factor of the cubic, and so is this linear x plus 1. So now what we can do, ladies and gents, is write down that this cubic, x cubed, plus 6x squared, plus 8x, plus 3, divide by this linear, x plus 1, is equivalent to this quadratic, x squared, plus 5x, plus 3. We can take the x plus 1 to the right hand side. So if I do this, I get that the cubic is equivalent to the linear multiplied by the quadratic. So essentially what we've done is we've taken the cubic and we have factorized it. And this is the form that we wanted over here. X plus or minus p in brackets multiplied by ax squared plus bx plus c in brackets. We've got the desired form. Let's move on to part B. Now we're going to take this cubic and we're going to divide it by this linear. We set up the bus stop. So here's the bus stop. Put the cubic inside. And the linear, which is the divisor, outside. Okay, so now we start the division. The first term is 2x cubed. You divide by the first term over here, which is x. If I divide these two, I get 2x squared. Now I take 2x squared and I expand it with the x minus 6. So 2x squared times x is 2x cubed. 2x squared times minus 6 is minus 12x squared. We then subtract these two polynomials. Okay, so 2x cubed take away 2x cubed is 0. Minus 15x squared minus 12x squared is minus 15x squared plus 12x squared, which is minus 3x squared. We can bring down the positive 14x and the positive 24. Right, so now we take this first term minus 3x squared and we divide it by x. If I divide these two, I get minus 3x. We take the minus 3x and we expand it with the x minus 6. Doing this gives me minus 3x times x is minus 3x squared. Minus 3x times minus 6 is positive 18x. We now subtract these two polynomials. So minus 3x squared minus 3x squared is just 0. 14x minus plus 18x gives me minus 4x. We can bring down the positive 24, and there you have it. Okay, so now we take minus 4x and we divide that by x. This gives me minus 4. So minus 4 multiplied by x is minus 4x. Minus 4 multiplied by minus 6 gives me positive 24. We can subtract these two polynomials, and if we do this, we just get 0. Again, that 0 over there at the end is the remainder. Since 0 is the remainder, we can conclude that this quadratic is a factor of the cubic, and so is the x minus 6. Okay, so we can take this cubic, 2x cubed minus 15x squared plus 14x plus 24, divide it by x minus 6, we get the result of this quadratic, which is 2x squared minus 3x minus 4. So if I take the x minus 6 to the right hand side, I then end up with a factorization for the cubic. And the factorization is just x minus 6 in brackets multiplied by 2x squared minus 3x minus 4 in brackets. And that is exactly the form that we needed, this form over here. So ladies and gents, that completes part A and B of my examples. Moving on to C and D. So in part C, we are going to divide this cubic by this linear. In part D, we are going to divide this cubic by this linear. Let's have a look at the two cubics. Now for the first cubic, we have an x squared term missing. For the second cubic, we have an x term missing. I tend to say to my students that these cubics are injured. We need to repair the cubics. Right, so to repair this cubic, we need to introduce a 0x squared term. To repair this cubic, we need to introduce a 0x term. Anyways, let's go ahead with the division. So for part C, we are going to start off by drawing the bus stop sign. There you have it. Inside the bus stop, we have the cubic minus 3x cubed plus 0x squared plus 50x minus 8. Outside the bus stop, we have the divisor, x minus 4. So my first step is to divide the first term inside the bus stop with the first term outside. So minus 3x cubed divided by x is minus 3x squared. We then take the minus 3x squared and we expand it with the x minus 4. So minus 3x squared times x is minus 3x cubed. Minus 3x squared times minus 4 is positive 12x squared. We take these two polynomials and we subtract. So minus 3x cubed minus 3x cubed is 0. 0x squared minus plus 12x squared is minus 12x squared. We can bring down these two terms as follows. Okay, now we take the first term over here and divide by the first term over here. Minus 12x squared divided by x is minus 12x. We take the minus 12x and we expand it with the x minus 4. So minus 12x times x is minus 12x squared. Minus 12x times minus 4 is positive 48x. Okay, so we now subtract these two polynomials. We see that minus 12x squared minus 12x squared is just 0x squared. 50x minus plus 48x is 50x minus 48x, which is 2x. We can bring down this number, so we can put the minus 8 over here. Now we take the first term for this linear, which is 2x, and we divide by the first term here, which is x. 2x divided by x is just 2, in other words, positive 2. We take that positive 2 and we expand it with the x minus 4, so 2 times x is 2x, and 2 times minus 4 is minus 8. Subtract these two polynomials, and if we do this, we get 0. That 0, ladies and gents, is the remainder. Since the remainder is 0, we can conclude that this quadratic is a factor of the cubic, and so is this linear. Right, so we've got minus 3x cubed plus 50x minus 8 divided by x minus 4 is equivalent to this quadratic. We can multiply both sides over here by x minus 4 to give us the following result. And that there, ladies and gents, is the factorization of the cubic. And it is the form given in the question. Okay, let's move on to the next part, part D. We're going to set up the bus stop sign. Put the cubic inside the bus stop, so we have x cubed plus x squared plus 0x. Remember, we have to repair the injured cubic. Minus 36. Put the divisor on the outside, which is x minus 3. Okay, so the first step is to take the first term inside the bus stop, divide by the first term outside. So x cubed divided by x is just x squared. We take x squared and we expand it with the x minus 3. This gives us x cubed minus 3x squared. Right, so we have to subtract the two polynomials. X cubed take away x cubed is 0. X squared minus 3x squared is x squared plus 3x squared. That is 4x squared. We can bring down these two terms. Right, so now we divide the first term over here, which is 4x squared, with the x over here. So 4x squared divided by x is just 4x. In other words, positive 4x. We take the positive 4x and we expand it with the x minus 3 to give us 4x squared minus 12x. Now we subtract these two polynomials. Okay, so 4x squared take away 4x squared is 0. 0x minus 12x is 0x plus 12x. So that is just 12x. Bring down the minus 36. Take the first term over here, divide by x. That gives us positive 12. Take the positive 12 and expand it with this to get 12x minus 36. Subtract these two polynomials and you get 0 at the end, which is the remainder. Since the remainder is 0, we can conclude that this quadratic is a factor of the cubic and so is the linear. So we have that this cubic, x cubed plus x squared minus 36 divided by this linear, x minus 3, gives us precisely the quadratic. Multiplying both sides by x minus 3 gives us the factorization of the cubic. So we have x cubed plus x squared minus 36 is equal to x minus 3 in brackets multiplied by x squared plus 4x plus 12 in brackets. And that there is a factorization of the cubic, and it is actually the form that we needed in the question. So ladies and gents, this is the end of my examples, and now I'm going to go through an exam style question. Here is an exam style question. F of x is equal to 2x cubed plus 3x squared minus 8x plus 3. This cubic is completely fine, it's not injured, we don't need to repair it because it's got all the terms included. Part A, show that f of x can be factorized in this particular form where a, b and c are constants to be found. Okay, so we know that 2x minus 1 is a linear factor of the cubic. We can use this linear factor to find the quadratic factor via polynomial division. So we're going to carry out polynomial division. So here is part A. I've got my bus stop. Inside the bus stop, I can put my cubic, so 2x cubed plus 3x squared minus 8x plus 3. Okay, so that is my cubic. Outside the bus stop, I can put my linear factor, which is 2x minus 1. Right, so first of all, we take this first term and we divide by the first term here. If we do this, 2x cubed divided by 2x is just going to give me x squared. We take the x squared and we expand it with the 2x minus 1. This gives me 2x cubed minus x squared as follows. Right, so now we subtract the two polynomials. 2x cubed take away 2x cubed is 0. 3x squared minus x squared is 3x squared plus x squared, which is 4x squared. We bring down these two terms. Right, so the first term is 4x squared now. We divide this by 2x. 4 divided by 2 is just 2. X squared divided by x is x. So we have positive 2x. We take the positive 2x and we expand it with the 2x minus 1. So if we do this, we get 4x squared minus 2x. We subtract these two polynomials. Okay, so 4x squared minus 4x squared is just 0. Minus 8x minus 2x is minus 8x plus 2x, which is minus 6x. We can bring down the positive 3. So the first term is minus 6x now. We take minus 6x and we divide by 2x. So minus 6 divided by 2 is minus 3. X divided by x is just 1. So dividing these two gives me minus 3. Take the minus 3 and expand it with the 2x minus 1. This gives me minus 6x plus 3. We can subtract these two polynomials, and if we do this, ladies and gents, we get 0 as our remainder. Okay, so since the remainder is 0, this is the quadratic factor of the cubic. So the factorization of the cubic f of x is 2x minus 1 in brackets multiplied by x squared plus 2x minus 3 in brackets. Right, now we can read off the a, b and c. A, the coefficient of x squared is 1. B, the coefficient of x is 2. And C, the constant term is minus 3. Let's move on to part B. So in part B it says, hence, we have to refer back to our answer in part A. So this answer over here. Factorize f of x completely. Let's have a look at part B. We know that f of x is equal to this factorization. we have to completely factorize this particular function. Okay, so the first bracket is just 2x minus 1. This quadratic will factorize into double brackets. So we've got double brackets. We can put the x inside each bracket. Now we need two numbers that multiply together to give me minus 3, but add together to give me 2. These two numbers are positive 3 and negative 1. Okay, so that is the complete factorization. Let's have a look at part C. Part 1. So we want to find the roots of f of x equals 0. So we set the brackets equal to 0. Which leads on to the roots of f of x equals 0, and these roots are x equal 1 over 2, x equal minus 3, and x equal 1. Okay, part 2 of the question. Now we want the roots of f of x minus 1 equal to 0. Okay, we know that f of x equals 0 leads on to x equal a half, x equal minus 3, x equal 1. So if we've got f of x minus 1, we are technically replacing the x's with x minus 1. Okay, so we have that x minus 1 could equal a half, x minus 1 could equal minus 3, and x minus 1 could equal 1. So now we rearrange and we get the values of x for which f of x minus 1 is equal to 0. So first of all, we have x equal a half plus 1, which is just 3 over 2. Then we have x equal minus 3 plus 1, which is minus 2. And then x equal 1 plus 1, which is 2. Okay, so these are the roots of f of x minus 1 equal to 0. Now, if you're thinking about the solution geometrically, what you need to think about is transformation. F of x to f of x minus 1 is a horizontal translation by 1 unit to the right. So essentially, we're taking these x-intercepts and we're shifting it 1 unit to the right to give us x equal 3 over 2, x equal minus 2, and x equal 2. Let's move on to part 3. Now we want the roots of f of 2x equals 0. We know that f of x equals 0 leads on to x equal a half, x equal minus 3, x equal 1. Now for f of 2x, we're replacing the x's with 2x. Okay, so we're trying to solve f of 2x equals 0. We can replace the x's with 2x. So we have 2x, firstly, is equal to a half. Then 2x is equal to minus 3. And then finally, 2x is equal to 1. We need to divide each side of these equations by 2, and that will give us the roots. So a half divided by 2 is just a quarter. Minus 3 divided by 2 is just minus 3 over 2. And 1 divided by 2 is just a half. So that there is the roots of f of 2x equal 0. If you want to think about the answer geometrically, well, you say to yourself, how do you go from f of x to f of 2x? Well, over here we have horizontal stretch by scale factor 1 over 2. So we're taking the x coordinates and we're dividing by 2, keeping the y coordinates fixed. So these are my x-intercepts. If I take each of the x-intercepts and I divide by 2, ladies and gents, I get 1 over 4, minus 3 over 2, and 1 over 2 respectively. And that there, ladies and gents, is the end of this teaching video, 7.2, dividing polynomials. If you found the video useful, please don't forget to subscribe, leave a like, leave a comment, turn on your notification bell so that you receive notifications every time I post teaching videos.